If you want to excel in maths and science, then do click on the link given in our description box and visit on the website of Infinity Learn by Sri Chaitanya and do enroll on our Don't Memorize course, which you can avail up to 90% discount. Here you can enhance your maths and science skills with the help of our conceptual videos, flashcards for quick revision, mock test as per latest pattern of your exams with 24/7 doubt clearance sessions with the facility of masterclass. To get extra 10% discount in addition, you can use our coupon code, that is NT10. So for more details, check out the link given in our description box. Hello everyone, so in this video we will be learning about electronic configuration, and there are some important relevant topics that we need to cover during electronic configuration. So let's move ahead with our topic. So friends, what is electronic configuration? Electronic configuration is mainly defined as the distribution of electrons into the orbitals of an atom. So friends, this is our atomic structure, and at the center we will have nucleus, and there are fixed path around the nucleus. Okay, so these circles, this yellowish circle will be known as our first shell, that is denoted by K, our second shell which is denoted by L, then third shell is denoted by M, and our last fourth shell is denoted by N. And according to Bohr's atomic model, there are fixed path around the nucleus. So these shells, or you can say orbits, have a fixed path on which the electrons revolve around this nucleus. So as the number of shells increases, their energy level also gets increases. So friends, as we have just studied, these circular paths are called as shells, and within every shell we have some subshells, and these subshells are denoted as small s, then P, then D, then F. So if we talk about our first shell, then the value of L is denoted here angular momentum quantum number, and which starts from 0 and it moves till n-1 value. So when we talk about our first shell, then we get the value of angular momentum quantum number as 0, and we get one subshell. And when we talk about our second shell, then we get two subshells. In 3 shell we get 3 subshells. In 4 shells we get 4 subshells. So by this we can conclude here that number of subshells is always depending upon the number of shells. So with the help of this value of angular momentum quantum number, you can write these subshells easily. And if you want to find the values of L here, then you can use n-1 formula here, as when the value of n is 1, then the value of L will be 1 minus 1, we get 0. So the value of L here is 0. So to write this subshell, we can use this formula n L. Okay, n means the number of shell and L is denoted by the values here. And to write this alphabet on the place of this L, you can take help of this values. By 0 it means S, and if we try to find out by applying these things in a second shell, then n equal to 2 and L will be 2 minus 1 equal to 1. Okay, as we know that the values of L starts from 0 till n-1, and we have got value here 1. So 0 and 1 both will be taken if we talk about our second shell. That's why according to 0 our subshell will be 2s, and according to 1 our subshell will be 2p. So these are the relevant topics that you need to understand before coming up to electronic configuration. Now let's talk about our main topic of this video, that is electronic configuration. So if we want to write the electronic configuration of many elements, then we need to write these values here. If we talk about our first shell, that is n equal to 1, then we get one subshell. If we talk about second shell, then we get 2s, 2p as our two subshells. If we talk about our third shell, then we get 3s, then 3p and 3d values as our subshells. And if we take fourth shell, then we get 4s, 4p, 4d and 4f as our four subshells. So firstly we need to find out the number of orbitals that we will be requiring here. For this we have to apply formula 2l plus 1. So if we want to find the number of orbitals, then we can apply this formula 2l, 2, and s means value of L as 0 plus 1, then 2, 0 plus 1. First subshell, we will get only 1 orbitals. On our first shell, we can have the maximum number of electrons as 2. Now let's talk about our second shell here. If we try to find out the number of orbitals according to P, this P value, then P mainly have 2P here, mainly have 2, and P's value is 1 plus 1, then 2 plus 1 is 3. So we can take here 3 orbitals, and on a single orbital we can have maximum 2 electrons. So total number of electrons on P subshell can be 6. Now let's move to our third shell. Then here the number of orbitals in D case will be 1, 2, 3, 3, 4, 5, 5 as you can find here. So if you want to find value of 3D, then 2D is 2 plus 1 get 5. So the number of orbitals in 3D case will be 5, and the maximum number of electrons here can be 10. So for S we got 1, for P we get number of orbitals as 3, for D we get 5, then for F let's see 2, 3, F. 3F means 2, F will be R 3 plus 1. So by this we can get a 7. And we have got here the maximum number of electrons. So in case of S we get maximum number of electrons as 2. Here we got maximum number of electrons as 6 in P case, and in D case we got maximum number of electrons as 10. So in this, if we have number of orbitals as 7, then 7 double is 14. Okay, so here we will get the maximum number of electrons as 14. So as according to Aufbau's principle states that the subshell whose energy will be low will have the filling of electrons first. So by this we can write here 1s2 first, then 2s, then 2s after it will be 2p. So 2p, p in case of p we have to maximum number of electrons as 6. Then after p we will have 3s2, then we will have 3p6, then we will have 4s2. So we have written this electronic configuration according to Aufbau's principle. Now let's find out the electronic configuration of few elements. So our first element will be hydrogen, whose atomic number is 1. So the electronic configuration for hydrogen will be 1s1, and in this if we can draw orbitals, so we can have only the maximum number of electrons as well. Now let's write for helium, which is denoted by He, and its atomic number will be 2. So the electronic configuration for this will be 1s2. Number of orbitals here only 1, in which we can put now maximum 2 electrons. Now our third is lithium, whose atomic number is 3. So electronic configuration for this will be 1s2, then 2s1. So I am writing here the electronic configuration that we have got from Aufbau's principle. That was 1s2, 2s2, then 2p6, then 3s2, then 3p6, then 4s2, because it will be very helpful us while writing this electronic configuration of these elements. Then fourth one is our beryllium, which is denoted by Be, and its atomic number is 4. So the electronic configuration for this will be R1s2, then 2s2, and if we can draw, then for this 1s we can have maximum number of electrons as 2, and for this 2s2 we can have. Now let's come to boron. So boron atomic number is 5. So the electronic configuration for this will be 1s2, then 2s2, then 2p1. For 2s2 we have number of orbitals as 1, and in this case also for s we have number of orbitals as 1, in which we can fill maximum 2 electrons. In case of p we can have maximum number of 3 orbitals, but only we have here 1 electron. So this 1 electron you can fill in any of these 3 orbitals. Okay, so we have filled here. Now our carbon atomic number is 6. So the electronic configuration for this will be 1s2, then 2s2, then 2p2. As you can see here, we are following this pattern here. So now let's solve for our seventh element, that is nitrogen. And in nitrogen we have atomic number 7. So the electronic configuration for this will be 1s2, 2s2, then 2p. Now in nitrogen you can see here we have 3 electrons to fill. So we will fill all these orbitals here. Then our case come of oxygen, and oxygen have atomic number of 8. So the electronic configuration for this will be 1s2, then 2s2, then 2p4. Okay, so as have one orbital in which we can fill maximum 2 electrons, and in case of p we have number of orbitals 3, and we have to fill 4 electrons here. Okay, so firstly we will fill 1 in all these 3, but this fourth one you can fill in any of these 3. Okay, so let's fill here.